Okay, I believe people are coming in. Welcome to this webinar. This webinar is a DirectConnect webinar between Eaglet and Bausch+Lomb. And the purpose of this is to show how powerful the combination is between the eye surface profiler and Zenlens. And we are absolutely thrilled with Dr. Jason Jedlicka, who is going to present on the Zenlens and the combination with the eye surface profiler. Thank you so much for sharing your wisdom and your experience with both the Zenlens, of which you are the co-designer, and the eye surface profiler, the instrument you've been working with for a few years now already. Yes. And just a little bit of background for those who don't know Jason Jedlicka that much. He's an associate professor at Indiana University School of Optometry and director of the cornea and contact lens service there. And he is a diplomat at the American Academy of Optometry. He is the past president of the Scleral Lens Education Society and a fellow on past board member of the Contact Lens Society of America. And he is a great educator. He is an author and international presenter. So we are so lucky to have you here, Dr. Jedlicka, and we'll look forward to your presentation. I will just start this by giving a little bit of background about the eye surface profiler. Meanwhile, to all the people live here watching this webinar, if you have questions, please use the chat box to ask them. And if it's a very urgent question, we'll interrupt. But otherwise, we'll have some room or plenty of room for a Q&A at the end of the presentation. So, a transformation of scleral lens fitting is really happening right now, and profilometry is playing an important part in that. There's been a lot of research in the last few years, rising in the number of it, and because profilometry has made it possible to measure the sclera in high detail. And so that has resulted in a couple of new insights in that you cannot really predict in a meaningful way the shape of the sclera if you extrapolate from the cornea. And it's also clear that the sclera is actually much more asymmetric than the cornea is. And so when you have the knowledge and a device that can measure not just the full cornea, but also a large part of the sclera, you basically take away the guesswork out of the whole fitting process. And this is where that transformation gets a chance to take place. The eye surface profiler is a single shot, fast measuring device with about 500,000 data points. And on the cornea surface, we measure that at 2 micron accuracy and the sclera at around 10 microns. It measures the full cornea and therefore gives you all the corneal maps and parameters that you are used to with the placido-based device. And of course, next to that, it gives a lot of information about the scleral shape. The measurement process is fairly straightforward. You basically have to instill fluorescein, then you get a flash from 2 sides that illuminates the eye, and you can see the photos on the right there. It has a full coverage, and that then is processed into a 3D point cloud that describes the full shape of the eye. And this is just to give an impression about the kind of maps that you will see and the asymmetry that you will encounter. And as soon as you have that information, you can really start on an informed basis, start fitting your specialty contact lenses. What it basically then enables you to do is to analyze the shape of the eye in high detail. And of course, Dr. Jedlicka will really discuss that in a more detailed and a more applied method with scleral lens fitting, Zenlens fitting. but it basically gives you the tools to not just analyze, but also then fit the lens. And even for highly asymmetric protrusions, such as a pinguicula, you can find out exactly what the shape is. And with that, my part of the quick introduction is done, and it's my pleasure to hand over to Dr. Jason Jedlicka.
Are we good?
Yes, we are.
Awesome. Thank you so much, Arnie. And again, thank you guys for all taking time out of your day or your night, whatever time of day it is for each of us, to be here. And it is really a pleasure to get to talk about two amazing products that I've had a great opportunity to be very involved with, and that is Zenlens scleral and the Eaglet ESP, this eye surface profiler. And so I'm going to start this first section just kind of walking through a little bit of how Zenlens works and what are some of the unique attributes about the lens itself, the design, and then we'll move on into how we use the ESP to fit the Zenlens depending upon your preferred style, whether you want to use it just to guide your diagnostic fitting, whether you want to let the instrument do the design for you, whether you want to use the DirectConnect feature and literally do nothing but take the map and hit order. So we'll go through all the different ways that you can work with the instrument to create the lenses. So first of all, just again, this is strictly talking Zenlens design so that we're all familiar. But we talk about the three basic zones of a scleral lens design: the optical zone, which again just provides hopefully a reasonable alignment to the shape of the cornea for oxygen permeability and ocular health. It provides the prescription, obviously, whether it's a spherical or toric prescription. Moving out to the far periphery, we have the landing zone, or the haptic, or as we say in Zenlens terms, the APS, the Advanced Peripheral System. And for those of you who are familiar with other designs where you've got an edge design where you have multiple curves that all kind of work as a unit, that's kind of how the APS system works. It's a multiple curve system, which you can't change individual curves. They just work as a unit. And then between the two, we've got the bridge area, the mid-peripheral zone, which gives us our limbal clearance, but also with Zenlens, it houses the smart curve, which is really what kind of changed how we prescribe scleral lenses a lot a few years ago, and has simplified the process for many of us. So just some cute little pictures here, some video where you can see lens design changing. And this is just to highlight the features that Zenlens has with regards to the smart curve technology. Again, the smart curve is there to simplify your fitting process. It allows you to say, I want to change limbal clearance, or central clearance, or mid-peripheral clearance, or I want to change the edge, or whatever I want to do differently with my design. I know that I can change that lens locally and not have to have a whole bunch of other changes occur that I didn't want. And so this is just a picture, a little video showing what happens if we wanted to increase limbal clearance. We would simply change that limbal clearance curve, steepening up a bit. Smart curve flattens to balance that change, allowing you to keep the same central sag, base curve, and peripheral curves, and only just giving you that change locally where you wanted it. This also applies to increasing or decreasing your central clearance. If you are generally happy with a fit, you're happy with the let's say the alignment of the base curve to the cornea in terms of their relationship, and that your vault is even, but you just don't have enough, or you have too much, and you don't want to change the base curve. You don't want to have to change the prescription, but you simply want to push up or down your sag a little bit. You can do that through changing the smart curve as opposed to the base curve. And as you steepen or flatten your smart curve, the entire optic zone lifts or drops, and so therefore giving you more vault or less vault as you want. Then again, there are times when you want to say increase clearance in the mid-periphery or decrease clearance in the mid-periphery to better contour the shape of your cornea, or to change the prescription for any reason. You can lock in your central sag at point A here, and simply changing the base curve flatter or steeper with the smart curve adjusting to give you more clearance or less clearance along the mid-peripheral part of your fit. Therefore, again, better contouring your cornea, giving you a more aligned fit. So all these features are brought to you by Smart Curve, the way that you can change these aspects of your fit locally without having to reconstruct your lens from scratch. And then finally, the same concept applies to the APS zone. Of course, you can steepen or flatten that as you wish, and you're just moving that edge up and down in 30 micron increments. You can do this, of course, 360 degrees. You can do this in one meridian to achieve a toric alignment. You can also do this quadrant specific to better fit the shape of the eye. And then, of course, we'll talk in a moment, you can also microvault or put in localized areas of APS change as well. One of the other attributes of Zenlens that makes it convenient to use is the two different designs that are in your fitting set from the get-go. You've got option of working with both prolate and oblate designs, so that whether you've got a patient with a very steep cone or a post LASIK cornea or what have you, every combination of corneal shapes, you've got a lens in your fitting set that's going to give you a reasonable corneal alignment to work with from the beginning. You don't have to put on a standard design lens on a LASIK cornea, for example, and then order your lens 7 diopters flatter to accommodate for that corneal shape. You can pull a lens right out of your set that should approximate that corneal shape with some reasonable degree to help facilitate your fitting process, make it more straightforward. Some other options you have with Zenlens for further customization. You have optics. Of course, we can do, you can do spherical optics, you can do torics, and the front torics can either be ballasted with a dual elliptical slab off prism system, or you can use back surface toricity to lock in the lens rotationally and account for that rotation in your front toric optic. There's also a multifocal option available as well. This is a center near design with very customizable powers, zone sizes, as well as decentered optics to better align to the visual axis. Obviously, we have adjustable limbal curves where you can increase or decrease limbal clearance, as we mentioned in the Smart Curve walkthrough. Very simple to do, just simply ordering increases or decreases in micron increments, 25, 50, 75 micron steps, whatever change you feel is appropriate for that patient. Again, we have the customizable APS option where you can do steepen or flatten this haptic all the way around in one meridian, or both meridians independently, or quadrant specifically. Quadrant specific, you're simply going to customize them around the clock, just like you would on a 4-opter dial axis, 0, 90, 180, and 270. You can simply increase or decrease edge lift in 30 micron steps in each of those areas independently. And then again, as I mentioned earlier, the microvault option. This works great for patients with a pinguecula, with maybe some low-lying filtering blebs, just any type of obstruction on the sclera. And even sometimes we'll have patients who have broad areas where the fit is a little bit tight, and yet it's not an entire quadrant. And you can do a very broad, shallow microvault sometimes to help with other fit needs. So microvault comes very handy, and we will talk tonight towards the end of our discussion about how we use the Eaglet, the ESP, to help us in that microvault design process. Zenlens comes with some great markings. Your diagnostic set's going to have the lens engraved with its diagnostic number or code. It's going to also have these drill dots around the outside of the lens, which show you the point at which that lens should transition from vaulting to landing. And so again, this is just really helpful to make sure that we've got the appropriate lens diameter on our patient's eye, that we want that ring of 6 dots to be beyond the limbus, and yet not so far beyond the limbus that we've got a very sloppy or untidy fit. A standard Zenlens design is also going to come engraved with a serial number, and it comes in handy a lot of times to identify, make sure the patient's wearing the correct lens. We all know that as we go through a few remakes, sometimes patients end up with multiple lenses and they may come in with their lenses switched or wearing an old one unknowingly. This is a great way to quickly and easily find out, is the patient wearing the lenses that I think they're wearing? And then again, we've got markings there to show you where your toric meridians are on a front toric or toric APS. Again, you're going to have the hash marks at 3 and 9. You're going to have the black dot at 6 and the engraving at 12. And so this is going to help you identify lens rotation. So that's just a little introduction to some of the Zenlens capabilities and how the design works. We'll talk then now about how we fit the lens. Success. The concept of Zenlens is quite simple to begin with, and that is choosing the correct diagnostic lens. The goal is, if you simply choose the proper diameter for your patient's corneal diameter and you simply choose the right geometry, that's 80% of the way to success. And so let's make sure we get those two things right and not spend a lot of time trying to fix a lens which had very little chance of working to begin with. So we'll talk about how we make those selections. And then once the lens is actually on the eye, how we evaluate the fit for modification. Zenlens coming out with a new fitting set here in the next few weeks. So it's going to kind of change. If you've got a fitting set already, it's going to look a little different. I'm going to talk about the new set going forward and some of the attributes of that. You've got 2 options, and that is what we call the core set, where all the base lenses are spherical haptics. You also can have a toric haptic set as your core. So if you prefer to work with spherical lenses or torics primarily, you can order the fitting set that best works with your fitting style. In addition to the core base 24 lens set at the bottom, along the left side of both sets, you're going to have the smaller diameter Zenlens option. So these are 14/8 and 15/4 diameter lenses instead of 16 or 17. On the right side, you're going to have options in the base set that you did not choose. So if you prefer the spherical fitting set, you're going to have a half fitting set of torics, and vice versa. If you picked the toric fitting set for your base set, you're then going to have half a series of spherical options to work with as well. And so you might say, well, how do I know whether I should fit a sphere or toric? And that's, of course, where your instrumentation comes in to help you make that call. One other final feature of the new fitting set are the 6 gray spots you see at the bottom. These are empty spots in your fitting set for you to customize your set however you want. If you want to add some quadrant specific APS lenses, if you want to add some multifocals, if you want to add some bi-elevation lenses for your own purposes, you get to choose what lenses go in those sets that might help you to be more efficient in your fitting process. So again, I'm going to back up here just a little bit. Again, for those of you who don't fit Zenlens, those of you who do, you already know this, but just real quickly, the lenses come in 2 different diameters in the core set, and that's 16 and 17 millimeters. And the 16 millimeter series is made to fit on those that are average to smaller corneas, and the 17 is made for the average to larger corneas. And arbitrarily, we picked 11/8 as that cross point, and that's not 100% on every patient, but it's pretty good. And I would say to stick with that 11/8 reading and it is going to get you success most of the time. So smaller than 11/8, 16 millimeters, larger than 11/8, 17. Again, then you've got your prolate or steeper base curve options against your oblate series for those post-surgical, post-refractive, or patients with peripheral corneal elevations or nodules where you need more room in the periphery than you do centrally. Then, of course, once we put the lens on, refining the fit, you know how to do this. You're going to look at that clearance with your broad beam. You're going to also look with a white light optic section and gauge. Here again, if I look at my fluorescein band here, my vault, and I like the profile of my vault, meaning that I like the amount of clearance I have in the center, and I like the way that vault tapers toward the periphery, but it's just a little bit more or less than I want. I can simply order the lens with 50 or 100 microns more or less sag than my diagnostic lens that I put on. And it will then keep that same profile of lens to cornea fitting relationship. It'll just do it with a little more or less sag. Again, you can also change the base curve to alter that profile of vault as you need to. Moving out to the edge, then, of course, there's a variety of different things we can see that aren't ideal here. We can see some compression, we can see edge lift, we can see impingement, et cetera. And as we know, then once that diagnostic lens is on, to look for these things like the compression, like the impingement, where we've got a tight edge, or again, looking for signs of excessive edge lift that creates patient awareness and lens movement. These are all addressed with adjustments to the APS. Again, either going steeper, flatter, toric in these cases, as you see where we've got issues with either edge lift or compression in just one meridian, or quadrant specific as needed. Very easy to do, very easy to have consultants help with this process as well. I did want to mention the microvault application because we will talk about that in our case here shortly. Again, microvault is simply an area of localized adjustment to the edge fit. And typically it's done for things like a pinguecula. It can be done again for lower level filtering blebs. It can be done for other types of obstacles on the ocular surface. It's designated, as you can see in the picture there, with the 3 dots highlighted by the purple dash rings. You're going to have to give consultation the location of the microvault. And if your lens rotates at all, they'll need to know lens rotation so they can place that microvault in the proper place. They're going to need to know the diameter of that microvault from where it starts to lift to where it lands back down on the eye again. They're going to need to know the radius of that, how far that microvault is going to extend from the edge inward toward the cornea. And then they'll need to know the height that you want. And again, we will talk about how having technology really makes that so much more predictable in just a moment. So again, and obviously the Bausch+Lomb Zenlens products are going to be available in Boston Exo or Exo material choices. Great training and support available from the B&L SVP team. You've got several market managers covering the entire country that can do online training, can provide resources, can talk about fitting sets, and also then can provide one-on-one experiences for fitters with experienced fitters who can do an online or in-person office workshops and training sessions to help you. And one example of that would be I've done in the past where we've had individuals who have an ESP and are working with Zenlens and say, I'd like to know how I can be more efficient at using the ESP in my own practice for fitting Zen lenses, and the market manager for that practice will contact me or someone else who's got the equipment and say, hey, can you take an hour and do a one-on-one training online and go through cases and show how you use your instrument to better fit Zenlens to help get them up to speed on being maximally efficient with their device with the lens fitting. So that's something that's available through the SVP team as well. And so with that, just a brief introduction to Zenlens. Obviously, we could spend an hour or two getting into all the details, but I just wanted to put that basic idea out there for all of you who are not familiar with the design. And with that, I want to focus specifically now going forward on how we fit Zenlens with the ESP. And again, there are different ways to do that, different approaches. And I would say that how I do that depends often upon the results of my profilometry that I get. So if I have a patient in the chair who I know I'm going to fit in a scleral lens, we've discussed it, we know the situation, we know that this is the way we want to go. The first thing we're always going to do is get a map and analyze the eye ocular surface shape. And that immediate map is going to give you so much information about that patient, not just, of course, for that immediate lens design, but it's going to help direct you into looking at that map is going to help you decide, gosh, this is going to be, should be a pretty straightforward fit. high success rate. I can be optimistic with my patient. We're going to make this work. It's going to show me whether I've got a highly irregular shaped eye and I need to move into a more complex design so that I don't try fitting them with very basic lenses and then find myself reordering with modification, trying to improve the fit. It's going to really set me up for predicting how this fitting process is going to go. And so again, that's the beauty of having that information from the beginning. So I want to talk just simply about diagnostic fitting of Zenlens using my ESP information. So here's an example of a patient from my practice who has actually had, she's post LASIK. And as you look at this map, you can see a couple things. One is you can see I've got a fairly flat central cornea, and I've got a corneal diameter here, which is noted. And in my results over here in my red circle, it's giving me my eye metrics, and it's giving me an HVID, VVID around 13 and 12.8. Now, every instrument is going to have their own criteria for determining this HVID. And for those of you who don't know already, Jen Harthen from ICO did a poster a year or two ago on comparing instruments and how they measure corneal diameter, quote unquote. And one of the things that they found was that using the ESP, it was measuring more the outer limbus rather than the corneal border. And so what I instruct everyone to do is just to subtract about 3/10 from my reading. And that's going to give me, this is speaking strictly in terms of Zenlens fitting. This is going to give me a predictor of which diameter to go with. So in this case, this patient's HVID 13.0. If I subtract 3/10, I'm at 12.7. That's still a large cornea. And so I'm going to choose a 17 millimeter design for this patient. And I'm going to choose my oblate series. So right now, I've just by looking at my map, I've narrowed it down to 25% of the lenses in my fitting set as options. And I know that's going to be one of these 6 lenses that's going to be the best lens, not any of the other of my set. So then here's another case where, again, just that initial map tells me so much. Here's obviously a patient with a keratoconus patient with a steep central cornea. Clearly, based upon this map, I'm going to go to my prolate design geometry. And I'm going to look over here at my HVID, VVID measurements around 11.9. If I subtract 0.3, it's going to be about 11.6. And then again, for my purpose, that means I'm going to choose my 16 millimeter lens diameter. So just that first step of taking a quick look at the shape of the eye, looking over at my eye metrics, giving me an idea of that corneal diameter. And that's going to then drive me into selecting the proper diameter and the proper geometry for my patient. Now, beyond that, there's other things that we can certainly do. Let me back up to this one again. I don't have this on here, but on my display, I certainly can, once I've decided, for example, on a 16 millimeter lens diameter, I can simply take my lens and move to a chord of 16 millimeters, and it's going to give me the sag of the eye at 16 millimeters and the degree of ptericity, et cetera, et cetera. So I can use that information to quickly go pick the ideal diagnostic lens for my fitting set in terms of depths. Again, as I said, in the fitting set, you've got 6 different lenses within a certain diameter and geometry. Which one do I pick? Well, just dial up the diameter you want, and it will give you that sag information, and you can pick. So again, having this data, you should be able to go to your fitting set and have the right lens or the best lens out of your fitting set for your patient. 95% of the time, it's a one and done process. I put a lens on, it's the best lens I've got. I over refract, check for modifications, pop the lens off, and I'm done. And that's my whole fitting process. And again, it's made so much more efficient and quick by knowing that that first diagnostic lens I put on that patient is going to be the best one almost every time. Couple other things that are important, and these may be terms that you're not familiar with, or maybe you are, but one of the things that has really opened up my eyes or had my eyes open to because of this technology and because of the ESP is this concept of the contribution of the cornea and limbus to the overall shape of the eye, and how we need to account for that when we are fitting scleral lenses. Again, we know there's the three zones of a scleral lens. There's the optic zone, the limbal clearance curves, and then there's your landing zone, your APS, your haptic. But that point at which that lens comes down to a landing point on the eye is never completely even all the way around the eye. And so in situations where we've got a significant difference in elevation at the initial point of landing in our two major meridians, we really need to be accounting for that by building toricity, not just into our haptic or our APS, but we need to put toricity where the toricity is needed. And sometimes that's inside the vaulting aspect of our lens, and sometimes it's outside. And again, it can't be more straightforward than when you have this type of technology to help you. So this is a patient where if you look at this topography, you say this is a significant amount of regular toricity. And clearly this patient needs a toric lens of some type in order to get a proper fit. And, you know, go back 5 or 10 years, I would have just fit the patient with a toric haptic the best I could, and they probably would have still had fogging and issues, but I wouldn't have known better what to do. But now, one thing I do when I see a patient with a decent amount of toricity is we immediately will look at the cord length, which in this case I've dialed in 12.8. If you see under the sag height section, a cord length of 12.8, which is about the point of landing for a 16 millimeter lens where it initially lands. And I'm going to look at the sagittal height difference of my eye at that cord length. And in this case, you can see my sag height difference is over 300 microns. And so if I fit a lens with a spherical vaulting chamber, I'm going to have it land perfect in one meridian, and I'm going to have 300 microns of space between my lens where I'm supposed to land and my eyeball in the other meridian. And that just creates a sloppy fit that moves and pulls in debris. So in this case, what I'd want to do is I'd want to add in 300 microns of toricity inside my vaulting chamber, and then just put the rest in my haptic to achieve a proper fit. Again, here's another situation of an eye that has a significant amount of corneal toricity. Again, we often look at our scleral profile maps, and we immediately look at the sclera. You know, we're drawn to the bright blues and reds of the sclera, and we forget to look at our cornea. And you've got so much good corneal information to look at here, and we shouldn't neglect that. In this case, it's clear if you just look at the corneal map, this patient has a lot of astigmatism. And if you were fitting this patient in a corneal GP, no doubt you'd fit them in a toric lens. And why do we fit a toric lens? It's not for vision correction, it's for better fit. And so the same holds true with sclerals in a lot of ways. If we want to get a better fit, we've got to put some of that toricity inside the vaulting chamber. And so again, having the technology, I can immediately go to my cord length where I know that lens is going to start landing. In this case, a 17 millimeter lens is going to land around 13.6, and I see 300 microns. So what that tells me is when I go place my order, no matter what, no matter how else I'm going to do this, I'm going to ask for a 300 micron difference in my sagittal height at 13.6 with my lens. And I don't have a lens in my fitting set that has it, but I know I need it because my map told me I needed it. So again, here's just a few more cases. This initial patient we looked at earlier, within their cornea, they show about 100 microns of elevation difference. At the end of their fitting zone, they show 300. So in this case, this patient has 300 microns of toricity at the edge of the lens. Only 100 of that is coming from the corneal zone. Do I need to do by elevation or build in very different sags? Possibly not. In other cases, again, like the previous couple examples where that difference was 300 microns, certainly those patients need it. So again, this is just something now that's become a standard part of the beginning process of fitting on every patient, is to look and decide how much toricity do I have at the lens edge, How much toricity do I have at the beginning of the haptic? And that's going to dictate a lot to me about how I proceed through the fitting process at that point. Here again, that diagnostic fitting process. If I've got this kind of map and I'm looking at it, what I see here is I see a 90-degree meridian and a 180-degree meridian that are fairly even in elevation, but my 4 o'clock zone is a little bit more elevated. My 7 o'clock zone is a little bit more depressed. And these areas of steep and flat are not opposing each other. And so again, this person, just by glancing at the map, I'm thinking quadrant specific lens to be sure. Similar in this case, this is actually a patient who was initially fitted in just a simple toric, struggled with debris accumulation. Once they were moved into a quadrant specific lens, it resolved much of their symptoms. So that's obvious from looking at the maps, and the software can either do this work for us, or if we want to just use this to guide our diagnostic fitting, whatever is preferable for that individual patient. Again, here's a situation where we can use our instrument to help us with the fitting process. So we've looked at our map, we've decided on a diameter, we've decided 17 millimeters, we've decided oblate lens, but I want to know what lens to put on for my fitting set. Well, again, I can simply run through the first lens fit process and select, in this case, a Zenlens of 17 millimeter diameter and hit calculate, and it tells me I'm going to need a SAG of 4950. So that's going to be the lens that I pull out of my fitting set. Now, one of the nice things about the ESP is it's also going to give you a base curve recommendation, and this base curve may be different than your diagnostic lens, but it's going to help you to achieve the most aligned central fit. And so again, whether the diagnostic lens you put on has a different base curve than's recommended, this is a great way to try to hone in that base curve and get it a little bit more precise to the relationship with that cornea. And I do use that base curve recommendation a lot when we get to the order process. Again, another example of this utilization of quadrant specific. We can simply know, in this case, we've got a patient who's got a quadrant specific looking eye. We can choose the Zenlens quadrant specific, put in the diameter we need, and it's going to give us a SAG recommendation, as well as showing us, yes, indeed, it does look like you need a quadrant specific lens, because that 270 meridian is quite a bit steeper than the rest of my fit. So it's really helpful. Again, most of us aren't going to have quadrant specific diagnostic lenses. You may put on a toric, and you may know it from the beginning before you even put that lens on that this lens is probably going to not fit each of my 4 quadrants ideally. But if I've got a lens that looks reasonably close, then coming back to my first lens fit algorithm, it's going to help me to know how much to adjust each quadrant to get that to be a better quadrant specific lens. Again, so just another example of choosing that right base curve, the right APS. So one of the really nice things now is this DirectConnect option for ordering. And so we've talked about, doing a diagnostic fit, and you say, well, I'm going to do a diagnostic fit. I want to do it my way, and I'll call consultation, and I'll explain what I need and whatnot. And that's fine. You can certainly do that. We've also talked about how, the instrument can give you even more information, like the recommendations for your peripheral zones in a quadrant specific, for example. And that's great too. But if you've not used the DirectConnect option, it's really handy, because it's going to give you the opportunity to customize each of these different parameters, even as it pulls in the data that the instrument has measured for you. It's going to allow you then, if you want to tinker, if you want to put in there the final powers, and if you want to adjust anything from what your observation was, if you did some trial lens fitting, But then it's also going to send a copy of that map along to consultation. So they're going to have a better chance to evaluate what you're ordering and make sure that what you're doing makes sense. And it's going to help you get, again, a better chance of success when they have access to looking at those maps that you're fitting the patient from. So where you're going to find this, of course, is when you do your first lens fit process. At the bottom of the recommended lens parameters, you're going to find this DirectConnect box. And you simply need to click the box, and it's going to take you to your form to complete your order. And you truly can add all of the customized parameters that you want through that process. So again, this is the DirectConnect form that's going to pop up for you. And as you can see, it's going to have you put in a little bit of your practice information, but it's also going to then pull in all of the different parameters that you had decided upon: the diameter, the type of lens, the base curve, sag, et cetera. All this is going to be pulled in for you. It's even going to pull in the lens rotation based off the shape of the sclera and how that lens is going to position. And if you, let's say you put a diagnostic lens on that had slightly different parameters, and you said, well, I know it's saying flat 2, steep 2, but I want to go flat 2 by steep 4. You can simply modify that here. If you say the lens I put on was really close, but the sag was just a little shallow, and you want to change it to 5,000, great. It allows you to change what you see here in the DirectConnect page. Moving on then to the latter part of the DirectConnect, you're going to have options for putting in things like a multifocal, the HydroPeg coating. You can add microvault, you can add bioelevation. All of those things come up here at the end for you to do all of your special instructions for consultation to see what needs to be done. So everything here is going to take your data, and it's going to make it simple, and it's going to give consultation a lot of information, and it's going to allow them more than likely to give you better outcomes, because if they see something that that they notice that they think will give you a better outcome, it's going to allow them to contact you back and say, hey, I know you ordered this lens, but looking at the map, did you consider a bioelevation as an option? Well, I've never used a bioelevation. Well, let me talk to you about that, and let's talk about how we can get a better result based upon that. So here again is where the DirectConnect really comes into handy, because it's saving you time by pulling all this information in for you and sending it directly to the lab along with the information that they need. So let's go through that process again briefly. If I was going to order a lens, just a basic order here, again, I've got a situation where at 17 millimeters, it's giving me the fact that I need some toricity here, a few hundred microns of toricity. It's giving me my K readings. It's giving me all my eye metrics. It's helping me to pick the lens that I want. I'm going to try, again, a 17 millimeter oblate lens with toric peripheral curves, and perhaps I put the best lens out of my set on the eye, and I do some over refracting and adjusting of the fit. And I'm simply going to come back to my first lens fit here, and it's going to give me that guidance for my diagnostic fitting if you want. Again, as you get more comfortable with the instrument's power and how the Zenlens algorithms work, and if you feel like the map is a really good quality map like we've got here, you may bypass the diagnostic fitting process completely, especially if you've got a history of GP lens wear with a known power and base curve. Because as you see off to the right here, we can put on our previous lens's base curve and power, and it can literally calculate out that lens. So you could theoretically order your lens straight off of your scan, just inputting some way of measuring that patient's prescription information. So again, here we go to the DirectConnect. We click and it pulls everything into our order page for us. And if there's any special instructions, we can put that in as well. And we simply hit submit, and our lens is off to manufacturing. Now, in some cases, it can be a more advanced process of ordering a lens. So I picked kind of an ugly eye here to work with, but that's okay. This is a patient clearly that's got some keratoconus going on, and perhaps even a little bit of some a broad cone, like a pellucid situation. They've also, obviously, by the picture on the right, the little blue circle showing you a pinguecula, and this is a complicated eye. And what happens sometimes is, we get into these eyes with some real wild shapes, and we're going to look at this and say, well, I think I need a quadrant specific because my 4 meridians look pretty different. But because of that pinguecula, it's really going to throw off our predicted data, because the algorithm doesn't know necessarily that we're going to put a microvolt there at this point. So it's just saying, based upon the fact what I've got, you should go really flat at, axis 330 over here. Well, in reality, we know that what we're going to do is put a microvolt there. So we're going to use the guidance from our first lens fit here, or at least I would. I know that I still probably want a quadrant specific lens. I know I want a 16 millimeter diameter, etc. My sag is picked, my base curve is picked, but I'm going to fine tune my APS in my order when I get to that stage based upon what I've got. So again, one of the nice things is you have so much ability to work with the maps and to use your data points to check localized elevations, and you can rotate that point anywhere, and you can rotate the chord anywhere you want to look at it. And so in this case, what I'm simply doing is I'm moving my cursor around here, and it's showing me, I'm moving to my major points of elevation and depression, and it's showing me the true elevation in those spots. And so based upon what I've got here, if I kind of ignore what's going on at my pinguecula, I can get my other 3 meridians pretty well nailed down. And my instrument recommendation from the first lens fit was actually quite good for those 3 quadrants. Now I'm going to come back to my area of my pinguecula, and I'm going to use my data cursor then to help design my microvolt. And I apologize for the quality of some of these images. I kind of had to screen capture them off my computer. But if we look at the area where the pinguecula is at, the first thing I want to measure down here at the bottom right on letter H is where is that pinguecula located? And here you can see it's going to give you the axis of rotation, so we know where that is located at. And then what I want to do is I want to take my data points and I want to measure the elevation of my sclera above and below those points, and then on top of it as well. And what this is telling me again is that the elevation above and below my pinguecula is actually pretty comparable to my 2 other flatter quadrants, but I need to add an elevation in that spot of about 250 microns to get up over the pinguecula. So I can determine from this the axis that I need my microvolt placed. I can measure the extent of it from my data points, how many millimeters I need, and then I can also know the elevation that I need in that spot simply by hovering my data cursor over these different points. So then when I come back to go ahead and put in my DirectConnect order, I've got all my input, and all I have to do is I'm going to go ahead and change my APS-1 from flat 20 to standard, because it's very similar to my APS-2 and APS-3, but then I'm going to go ahead and put in the specifics of my microvolt. So I want a 3 millimeter diameter with about a 300 micron volt at axis, give into account the rotation of 151. I needed to do Lars and adjust that, and my axis came out to be 18 degrees. So again, now with this, I can send this off to consultation, and I'm going to get my quadrant specific lens with a microvolt built in to accommodate my pinguecula right off the bat with my very first lens order, without having to order a lens that doesn't account for these things and then modify it later if I need to. So with that, I'm going to draw my presentation to a close, and we can just take some questions. Hopefully, this is kind of a quick walkthrough. There's so much potential and so much power within the ESP for lens design, and for not just lens design, but really understanding our patients' eyes that we're fitting, that I just really enjoy being able to sit and analyze the eyeball that I'm working on. And what's really cool, of course, is when you look at a map and you see the shape of the eye, and then you decide, well, I'm going to put this lens on but based upon my map, I'm going to expect to see the lens is going to be a little bit loose or a little bit tight there. And you put that on and you say, it's spot on from what my map predicted. And that happens so often. And it's encouraging and it's fun. And it just makes the whole process so much simpler and efficient. So with that, Arnie, happy to take any questions. So
I see there's a couple of questions. One from early on in the presentation, and that is from James Hill, who asks, will the new core set be priced similar to the current sets?
That I cannot say, but I will just say I think that for people who already have a fitting set, you'll simply be able to get the new case, transition your old set into it, and then there'll just be an upgrade fee for finishing out your set, so to speak. So I don't think you have to buy a full, complete new set. If you've already got a set and you just want to upgrade to the newer set, I think it's a pretty minor cost to make that transition. Yeah.
Okay. Also from James Hill is the question, is DirectConnect working with EMR such as Epic, sending direct information to a lab, or will be a big IT build at our university?
Yeah, so again, this is, and I can't speak to everybody's unique IT situations, but this is something which is in the computer, which drives your instrument, which drives your ESP. This is in your ESP software, and it's all through that software. So it's not pulling anything out of your EMR. It's pulling it out of the data that you've extracted from your patient through the map and whatever else you've inputted then, like refractive information. So I can't imagine this would be difficult at all or awkward, even if you're in an institution that has limitations. I'm at a university, and it doesn't impact my ability to do this easily at all.
Okay. Thank you. And then there's a question from Robert Martin. When using the elevation, do you find that the higher difference makes a bigger impact?
Yeah, I would say that I feel like in a lot of ways, it's just like the whole notion that when you change a base curve on a lens you don't change it by a quarter diopter. You'd rather make bigger changes. And if you go too far, at least you saw, oh, well, I guess I overshot. Now I know I need to be somewhere between here and here. If you go too small, you might look and say, well, I don't know if that made that much of a difference. Well, what if you didn't go near far enough? So I say yes. I say when in doubt, actually overshoot a little bit and prove to yourself that you've gone far enough. And if you've gone too far, at least then you know your ideal place is somewhere between 1 and 2.
Yeah, awesome. And then there's a question from Artem Verbitnik. He said, could you please repeat about whom I should ask for more training? Well, training is definitely something that Eaglet Eye provides. So we have very intense training of new users. There's a bit of self-training online, and then we do a number of Zoom calls with all the people working with the Eye Surface Profiler. And next to that, of course, there's a lot of training material with the Scleral Lens Education Society. There's all kinds of other courses ongoing. And, just contact us. We'll be very happy to point you in the right direction there. I hope that answers your question. And then we have from Abraham Albower, just clarifying, he says, the by elevation will most be based on if there is a large sag difference at the closer chord. Is that correct?
Correct. So when you have a situation where the area under the lens where you intend to be vaulting, so that's going to be from the center of the lens out to the point of first landing, the beginning of the haptic. in that zone, in that core diameter, whatever that core diameter is, if you've got a significant amount of toricity, that would then be incorporated into the smart curve and the limbal clearance curves of the lens. It is still a spherical base curve, so you don't have to get into complex optics of bitorics and, CPE, SPE, bitorics, things like that. It is still a spherical base curve. The toricity is built into those mid-peripheral zones, but it still accomplishes the fact of landing that lens down at a point that's appropriate for the elevation in each of the individual meridians.
Awesome. And then I see one more question from Royland Sams. To what degree do you still consider the settling of the scleral lens when fitting with the ESP versus without?
Yeah. Well, of course, everybody's eyes are different in terms of the settling. Some patients settle a little, some a lot. And of course, the software is going to have that built-in factor. So when you go to your first lens fit, for example, I didn't point this out, but it will say in there, it'll give you a clearance factor. And I think the default on my instrument is 250. And, through your own experiences, you use it more and more, you're going to find that with your go-to lenses, that maybe 7 out of 10 times that vault is a little bit less than what you expected it, and the other times it's equal. And you'll say, yeah, I think I'm going to push that up, and I'm going to set my default to 300. So there is already a factor built in for settling, and of course, it's going to be different for every lens because I think lenses settle differently. And so I think, again, with your own personal experience with the way your instrument is set and with the lenses that you're fitting, you're going to find that if it's not pretty much right on, you just adjust your default clearance that you want to make it a little bit more ideal.
Yeah. And what I can add to that is that the algorithms in the eye surface profiler software, they take what the lab dictates as the average settling level, and so in that sense, that's integrated into the calculations.
Yeah, but you do have the ability to adjust that, and again, I would say if you again, we all fit different. I like to fit my graft patients with less clearance than my cone patients because graft patients have a broader area. They need more oxygen. My cone patients, I don't want that lens to settle down and touch the apex focally. So I might want to play with that. I might bring my graft patient clearance down by 25 or 50 and bring my cone up by 25 or 50. And that's just your own personal preferences, but you can set that in your settings.
Yeah, awesome. Thank you. Let me just quickly wrap up. From the eye surface profiler side, we put the spotlight on Zenlens, of course, in this webinar. But I would like to highlight that the eye surface profiler is also there to help you fit your specialty corneal lenses, both Ortho-K and RGP, and we, for all of those specialty contact lenses, we can help speed up the process, inform you better, empower the practitioner to make the right decisions. And also mentioned here, and I would like to highlight that a little bit further, is we've got an extensive e-learning center where you will have, at your own pace, you will be learning how to get great measurements with eye surface profiler in the shortest amount of time. And we have a training staff that will accompany you in that path. Again said, the spotlight is on Zenlens here, but we have an open platform, meaning that we work with all the labs who are willing to work with us. And this is just a small number of the total package. And we strive to add more every year. So, and then, well, with the Zenlens, of course, we aim to give you a faster process, fewer refits, and more control over the whole fitting process. That is the essence of the the power of the combination between the eye surface profiler and the Zenlens. If you have any questions, please contact us. This webinar will be available in a recording. We will send you the link afterwards. I'd like also to highlight that we will have some other DirectConnect webinars coming up on July 19th with Wave, 27th, Gaudi, 31st, ScanFit Pro, and in September with Boston Sight. And we hope to see you there. And meanwhile, a very big thank you to Dr. Jason Jedlicka for this wonderful presentation, very much practical, very much in depth about fitting Zenlens in general, but also, of course, with eye surface profiler. And we thank all of you who came to watch this live, and for those who watch it later via the video, enjoy and do let us know if you have any questions. And from all of us here, thank you and have a great evening. Bye-bye.